Question 8. Give the oxidation state of nitrogen in the following species. NO2 minus. Well, oxygen is going to be minus 2 times by 2, so minus 4. I know the molecule or the following species has the overall charge of minus 1, so how do I go from minus 4 to minus 1? Nitrogen must be plus 3. In this case, oxygen is minus 2, therefore nitrogen must be plus 2, overall charge of 0. Right, half equation for the conversion of NO2 minus acidic solution to NO. So first things first, I'd write down NO2 minus arrow NO. Then I'll be like, okay, I've got one nitrogen, one nitrogen there, perfect. However, I've got 2 oxygens here, 1 oxygen here, so I need to add a water molecule, H2O, right? Okay, that's fine. But now I've added this water molecule, I've also added 2 H pluses, which I don't want, which I can't get rid of, so I need to add 2 H pluses here. Then I look at the overall charge, and this is where I made a silly mistake. I wrote NO2 minus as this, so I thought it was minus 2 the overall charge. No, that's minus 1, that's the overall charge. Just because that doesn't mean that little 2 just means 2 oxygens, that's a minus 1 charge. So therefore 2 plus a minus plus 1, therefore I add 1 electron, negative charge electron. What I did was I added 2. Because I just read it wrong. Silly mistakes. And then half equation of conversion I minus and iodine. So I minus the iodine. In this case, I need to add 2 here. Once I've added 2 here, because I've got 2 iodines there, I want 2 iodines here. Got minus 2 charge. This is a minus 2 charge, but in this case, it wasn't. It was minus 1. Plus 2 minus there. Overall, ionic equation for reaction of this acidic solution with this. 1 electron here, 2 electrons here. Times this by 2. 2E minus plus 4H plus 2NO2 minus, I should say, RO2NO plus 2H2O. Whole thing by 2. Then what you should see is that the 2 negatively charged electrons cancel out. You add them together, you get this 4H plus 2NO2 minus plus 2N minus to form 2NO plus 2H4 plus I2. Some cases you can simplify it down even further, either by dividing by 2, but in this case obviously the iodine is 1, so you can't divide it by 2, even though it does look like you can't. Or by even removing H pluses on either side or water molecules on either side, and that's also another trick they like to include. Then state the role of NO2 minus in reaction with I minus oxidizing agent. Calculate concentration grams per dm minus cube of sodium nitrate in the sample. So first thing I know is that I've got sodium nitrate required this much of potassium chloride. So I found the moles, concentration and volume of the chloride ions, right? Then I'm going to divide by 2 times by 5, 2 to 5 mole ratio. I've got the moles of this. Then I'm like, I want the concentration. So moles of concentration, volume, concentration is the moles divided by volume, right? The moles is that, the volume is just going to be 25 times by 10 to the power minus 3. I'll get the concentration in moles per dm minus cube, but it says in the question, concentration in grams per dm minus cube. How do I go from the concentration in moles per dm minus cube to the concentration grams per dm minus cube? I need times by the mR. So I do 0.0548 times by the mR of sodium nitrite, which is 69, and I should get 3.78 grams per dm minus cubed. Section B, the multiple choice questions. I'm not really going to go through them in detail. It's just, just go through them. But I have gone through a lot of multiple choice question in detail. So if you would like, maybe I'd create a separate playlist on that then. If you guys would like that, just let me know in the comments. Question 9, which is the correct crystal structure for the substance named? Iodine, simple molecular, yeah. Just how well you know structures. Diamond, ionic, definitely not. Sodium chloride, giant covalent, no. Graphite, metallic, no. Which is the best technique to remove silver chloride that forms when aqueous solutions, silver nitrate and sodium chloride react? Refluxing, no. Evaporation, no. Filtration, yes. Which statement about acetine is correct? It's how well do you know your trends, and if you know your trends correctly, you should know acetine has a greater boiling point than bromine. Which statement about time of flight mass spectrometry is correct? The first one. The current detector is proportional to ion abundance. Sample particles gaining electrons form positive ions. Well, if it's gaining electrons, it's going to form negative ions. Particles detecting all the kinetic energies? No, same kinetic energies. Detecting all the masses or the size. Ions are accelerated by magnetic field. Ions are accelerated by electric field. So how well do you know time of flight mass spectrometry? Which statement about peaks in this is correct? It's peaks at MZ 70, 72, 74 in the ratio 96 to 1. What's the concentration of moles per mass cube of sodium sulfate in the solution? So first thing I would do is moles mass over MR. Then I know moles concentration volume, concentration moles divided by volume. I've got the moles, the volume is 250 by 180 moles per mass cube, so 10 by 10 to the power minus 3. You should get 0.137. Which of these contains the greatest number of atoms? Now, you could just, work out the moles and all of that, and then maybe time by Avogadro's constant, but milligrams of iodine, so I divide by 1,000, to convert it to grams, and then divided by the mR. In this case, I've got kilograms. In this case, I've got slightly more kilograms. So yeah, the answer is going to be D, contains the greatest number of atoms. With these kind of questions, which one is the biggest, or which one has the highest MR, or greatest number of atoms, you just need to work them all out, really. Ask for a blank sheet of paper and just go through all of them. 25 centimeters cube sample of sodium hydroxide solution taken by pipette from a beaker. These were then titrated with aqueous solutions of ethanoic acid. Concentration of ethanoic acid calculated from experimental results found to be lower than actual value. Which of these could we explain the difference? B. Rinsing a burette with distilled water before filling with ethanoic acid. What's the formula of metabromine? This one's a bit unusual, but the idea is I work out the moles of this, then I work out the moles of this, and then to work out the empirical formula, divided by smallest number of moles, you should get MBR2, right? That's how you do it. Which species has one or more bond angles of 90 degrees? ClF4 minus. Which statement is correct? If total pressure is increased, constant temperature proportion of CO, CO2 in the equilibrium mixture will decrease. Now I'm going to go through this one because this one's equilibrium, all of that. And all of these options do look, how would I know which one's which? Well, first thing I do is I see pressure, I'm counting the number of moles on each side, right? I know I've got 1 mole here, 2 moles there. So if I increase pressure, it's going to shift aside a few moles of gas. So which is left hand side, so CO, CO2 would actually increase, not decrease. Use for catalyst, increase proportion of cis in the equilibrium mixture. Nope, catalyst, no effect. Reducing the equilibrium concentration but increase value of equilibrium constant. No, only temperature can affect the value of equilibrium constant Kc. Reducing concentration, equilibrium concentration of carbon monoxide will not increase the value of equilibrium constant. And that also makes no sense because if I reduce this, well, products is going to be lower, reactants is going to be higher. So I'm going to have, like, for example, 2 divided by 10 instead of 2 divided by 5. Which one's bigger? 2 divided by 5. So Kc would actually decrease. That's not relevant because it says reducing this will increase equilibrium constant. Only temperature can affect value of Kc. Therefore, the answer must be D. And how do I know it's D? Well, if forward reaction is endothermic, delta H is positive. Increased temperature equilibrium shifts to the endothermic direction. The opposite increase in temperature, aka decreased temperature, which is forward reaction. So therefore, get more products over the same amount of reactants. For example, bigger number divided by same number. So I'm going to get Kc will be bigger. Which of these is not a redox reaction? So work out the oxidation states, right? In this case, copper +2 overall, 0, so that's change. Magnesium, so instead of working all of them out, just do these, just magnesium, copper, magnesium, Sn, Mn, right? Manganese. I can see with magnesium, in this case, that's +2. In this case, also +2. The oxidation state's not changed at all. It's the same, so it's not a redox reaction. Which of these has the highest first ionization energy? Chlorine, Cl. What is the empirical formula of an oxide of nitrogen contains 26% nitrogen by mass? So first thing I would do is work at the moles, mass of Mr, so 26 divided by the Mr of nitrogen, 14, and then the ratio to oxygen, 16. No, sorry. Yeah, I've done this wrong. Done this horribly wrong. 26% nitrogen, it's only got nitrogen, oxygen, therefore the percentage by mass of oxygen is going to be 100 minus 26, and divided by then the MR. So it'd be 100 minus 26, so 100 minus 26 divided by 16. And then you divide by smallest number of moles, and you get N2O5. That was mistake by my end, hopefully. Sorry for that. Which species is not produced by redox reaction produce solid sodium iodine concentrated ferric acid? Now, I tried my best to recall these equations, but they are really annoying to learn. I just forgot them again already. But you should know for the first one, pretty simple. NaI plus H2S4 to form NaHS4 plus HI. I'm going to form NaHS4, not Na2S4. I don't form Na2S4. Hydrogen sulfide definitely produce that later on. SO2 definitely do. Sulfur, I definitely do, right? So therefore the answer is A, Na2S4. And this question is a classic example of why you need to memorize and know your equations very well. I clearly didn't, but I knew it decently enough to know that A was the correct answer that's not produced.